All right, let's take a look at lesson 11.7, area of volume and similar solids. So this lesson closely resembles lesson 10.4, where we looked at perimeter and area of similar figures. So, looking at this, first of all, we're going to take a look, and you can use the ratios to compare the areas of volumes of similar solids. So what is a similar solid? Well, it basically means it's the same shape, just different size. Similar solids have corresponding congruent angles. So all of their angles will be the same, that are correspond to one another, and the sides are going to be proportional, just like we were when we studied similar figures and similar polygons in chapter 7. So there are a few solids that are always going to be similar. These solids are cubes and spheres, because they only have one variable. There's only a side length in a cube. Every side is the same length. So therefore this would be the same as would compare to this, as this side would compare to this side, because these would be the same length, or just one is bigger than the other. Now spheres, the only variable in this one is going to be the radius. So as the radius gets larger, your sphere gets larger. But it still remains a sphere. So let's take a look at this, identifying whether two objects are similar. So they give us part A. Are these two rectangular prisms similar? If so, what is the scale factor? Well, in order to do this, we're going to find our corresponding sides. So we have 8 as the front here, 10 as the front over here, so we compare 8 to 10. Reduce the fraction, and that becomes, reduced by 2 becomes 4 over 5. Now we'll look at the next one. 3 compares to 4, so 3 to 4. And since 3 to 4 is already simplified, we can now tell that 4 over 5 is not the same as 3 over 4, so this one is not similar. Okay, we can also verify that by doing 5 to 7 and realize that is not similar as well. So let's take a look here at part B. Are these two similar? So as you look at this, you're going to compare the corresponding parts again. We have 10 corresponds to 15. We're going to have 4 corresponding to 6 down here. And then we'll have 6 correspond with 9, both the heights of these two prisms. So this reduces down to become by 5 and becomes 2 over 3. Reduces by 2 in this one, it becomes 2 over 3. And then by 3 in this one, this becomes 2 over 3. So we get 2/3, they're all the same, so this one is going to be similar. And our scale factor is going to be a 2 to 3 ratio. So it can be written as 2 to 3 this way, or 2 over 3. Both ways are acceptable. All right, so let's take a look at our rules for similar solids. If the scale factor of two solids is A to B, then the ratio of their corresponding areas is going to be A squared to B squared. And since we're talking about solids this time, we're going to talk about volumes, and so the ratio of their corresponding volumes is going to be A cubed to B cubed. So we start with the scale factor. Ratio of the areas is A squared over B squared, and then we have A cubed over B cubed for the volume. So let's kind of see how this works. Let's take a figure and actually calculate the surface area and the volume. So in this problem, it says that the surface area is equal to blank, volume is equal to blank, and they give us the dimensions here. So what is our surface area? Well, remember the formula for surface area. It's going to be the perimeter of the base times the height plus 2 times the area of the base. So in the volume formula, it's going to be area of the base times the height. So in this problem here, we find a perimeter. Well, we have 1, 2, we have 1 there, we have 2 here, 1 here, so we get 2 and 2, 1 and 1, which gives us 4 plus 2 is 6. So a perimeter is equal to 6. And therefore, the other part is our height. Height is going to be 3. That leaves us with finding now the area of the base. That's 2 times 1. It's a rectangle, so we get 2. So now to find the surface area, we're going to take perimeter of the base, which is going to be 6 times the height of 3. So 6 times 3 plus 2 times 2. So that gives us 18 plus 4. That gives us 22. So 22 meters squared is our surface area. Now the volume, area of the base, we know is 2 times 1 times the height is going to be 6. So we have 6 meters cubed. So we have 22 meters squared, and then we have 6 meters cubed. So let's find the surface area of the larger one. Well, for this one, the perimeter is going to be 4 plus 4, 2 plus 2. That's 8 and 4, which is 12. The height would be 6, the height of our prism. And then the last one here is going to be the area of the base. And that'll be 4 times 2, which is 8. So we plug these numbers in. Surface area is equal to 12 times 6 plus 2 times 8. So 12 times 6 is 72. 72 plus 16 is going to be 88. So our surface area is going to be 88, and this is meters squared. And the volume, area of the base is going to be 8. Height again is 6, so volume is going to be 8 times 6. That's going to give us 48 meters cubed. So let's take a look here. What is our scale factor? Well, the scale factor is going to be the ratio of the sides. So we get 1 here, compare it to 2 over here, so our scale factor is 1/2. Now remember, this is our A over B, so A over B is 1/2. So let's look at the ratio of the areas. So as we look over here, we look at our surface areas. One surface area is 22. The other surface area is 88. So if we simplify this fraction, 22 goes into itself once and it goes into 88 4 times. So the ratio of their areas is 1/4. So that means that this is equal to A squared over B squared. So this is the ratio of the areas. Take our scale factor and square it. And the last one we have to look at is the ratio of the volume. So in ratio of the volume, we're going to take our two volumes, and we have 6 cubic meters over 48, and see if this can reduce. And because 6 does go into 48 evenly, it's going to become 1 over 8. So this is our A cubed over B cubed. This is the ratio of the volume. So if I were to take my scale factor 1/2 and I square it, that means I'm going to get 1 squared over 2 squared, which is going to be 1/4, ratio of the areas. For the volume, that's 1 cubed over 2 cubed. 1 cubed is 1, 2 cubed is 8. So we get 1 over 8. So we're going to use these ratio of the areas and the volume and the scale factor help us find either missing areas or volumes. So let's take a look here at our next example. The square prism are similar. What is the scale factor of the smaller prism to the larger? So smaller to larger means we're going to put the 729 over 1131, or excuse me, 1331. So this right here, because of the volume, this is the same thing as saying this is our A cubed over B cubed. But we need to make sure that we simplify it. So we have 7 over 29 over 1331. Now, first thing we're going to do is, because we're looking for A over B, what is the scale factor? Well, the way to get this is I'm going to take the cube root, and I'm going to take the cube root of the other one. So that gives me A over B. So now we're going to find the cube root of each of these. The cube root of 729 will come out to be, let's see here, cube root. So the cube root here is going to be 9. So we get a 9 here. And now we're going to do the 1331, so the cube root let's look here. We got the cube root. Let's try this again. Math 4 cube root of 1,331. That gives us 11. So 9 over 11 is our A over B. So this is our scale factor. So we get 9 over 11. Okay, so next I want you guys to try part B. Stop the video, work it out, and come back and check your answer. All right, so let's see how you did. You should get a scale factor of 2 to 3. We start out with our A squared over B squared equals to 144 over 324. So because we're looking for A over B, we're going to take the square root of A squared over B squared and square root of 144 over 324. Now, you could have simplified here first before you multiplied, or you can do the radical and then simplify your answer, which is what I did here. So A over B is equal to 2 over 3, and that is our scale factor. All right, so let's look at the next one. What is the scale factor of the similar rectangle or prism shown below? Once again, they give us the volume of both, so I want you to calculate this measure. Now, one hint, as you're working these, if it's not a perfect cube, then you need to simplify it before you try to take the cube root. So let's try to work, I guess we'll work this one together, kind of make it more understandable. So we have the volume of both. So that means we're going to use the ratio of our volumes, which is A cubed over B cubed. Now, the volume of this one is going to be 3375, and the volume of this one is 1728. So now we're going to take the cube root. So as you plug this in your calculator, we're going to see, is this a perfect cube or not? So we got math print here, we got number 4, we got the cube root of 3375. And it is 15. So we simplify here to become 15. So let's see if 728 is a perfect cube. So we get the cube root again. Try this again. And so we're going to take our bottom number now, which is 1728. And that's going to give us 12. So we get 15 over 12, and we can reduce this number down by 3, and this becomes 5 over 4. So we have our scale factor of this one is going to be 5 to 4. So far we've taken volumes and areas, and we found our scale factor. So let's use this to help us find either an area or a volume. So in example 3a, the volumes of two similar solids are 128 cubic meters and 250 cubic meters. What is the surface area of the larger solid? The surface area of the larger solid is 250 square meters. What is the surface area of the smaller solid? So as you're working this, it's important to always find your scale factor first. So in order to find our scale factor, they give us two areas of our similar solids, which means we're going to use this to find our scale factor. So they've given us the volumes, which is going to be A cubed over B cubed. And this is going to be equal to 128 over 250. Now, once again, we're trying to find the cube root. So you'll notice here that the other problems I put cube root on both of these. And you can write it like that, or you can separate them or keep them all together. But because they're separated by division here, we can simplify if they're both under the cube root. So let's take a look here. We have the cube root of A cubed is going to be A. The cube root of B cubed is going to be B. So now it's time to simplify this number here. Now, 128 is not a perfect cube. So we'll check it just by plugging this in. Perfect cube, 128. That gives us 5.039. So that means that this is not a perfect cube. So what we want to do is we want to try to see if we can simplify this. We know that 2 goes into both, so let's go ahead and take this and divide by 2. This is going to give me 64. This is going to give me 250 divided by 2, which is 125. Now, these are still underneath the radical. Nothing's been taken out yet. So, now, in order to find a over b, we're going to try to see that these are perfect cubes, and they are. So this cube root of 64 is 4, and the cube root of 125 is 5. So that gives us our scale factor for a over b is 4 to 5. So now, we're going to use this scale factor to help us find the smaller area. Now, in order to use this is our scale factor, so we're going to be doing area, which means we need to use a squared over b squared, which gives me 4 squared over 5 squared. So that means that our a squared over b squared is equal to 16 over 25. So we're going to use this number here in our proportion to find a missing area. So 16 over 25 is equal to, now this says surface area of the larger, that means it's going to go with the large number, which is on bottom, which means this is 250, over, we'll call x on the top, the surface area of the smaller figure. So once again, we're using the ratio of the areas to help find this. So we cross multiply. 25x is equal to 250 times 16. So we'll take 250 times 16. That will be 4,000. So we get 4,000. Now we're going to divide it by 25. So that's going to leave us with x being equal to 160. So 160 is our surface area. This would be, we are in meters, so it would be meters squared. Surface area of our smaller figure. Once again, take the cube root to find the scale factor. Use the scale factor to use the ratio of the areas, and use that result in our proportion to help find our missing area of the smaller figure. All right, so let's look at the next one. The volumes of 2 similar solids are 40 inches cubed and 135 inches cubed. If the surface area of the smaller solid is 48, what is the surface area of the larger solid? So you give this a try. So pause the video, come back and check to see how you did when you get done. All right, so your answer should be 108 square inches. So let's check it to see how you did. So we first start off with our 2 volumes, one of 40, and one is 135. So as I set this up, I'm going to take, this is my a cubed over b cubed. So I'm going to do the cube root of both. Now, neither of these are perfect cubes. So what we're going to do first is we're going to simplify these. So I know they both one ends in 0, one's in 5, so I know 5 goes into at least both of these. So we'll see if there's anything else. That means 40 divided by 5 is going to be 8. And that means 135 divided by 5 is going to be 27. Now both of these numbers that are remaining are perfect cubes. So this means that my a over b is going to be the cube root of 8, which is 2, over the cube root of 27, which is 3. So that means the ratio of our areas is going to be these two numbers squared. So this is our scale factor, 2 to 3. So we're going to use the a squared over b squared, which is going to be 2 squared, which is 4, and 3 squared, which is 9. So that's our ratio of our areas. And now we're going to use the ratio of our areas in our proportion to find our missing area. So it tells us here that, I'm going to go ahead and put our division line. If the surface area of the smaller solid is 48, what is the surface area of the larger? So 48 would be the smaller, 4 is smaller than 9, so it goes on top, and we put x on the bottom. So now we cross multiply. 4 times x is equal to 9 times 48. And 9 times 48 is going to give us 432. Divide this by 4. And x is equal to 108. And this will be inches squared. All right, so let's take a look at our last couple examples. Using the scale factor to find capacity. A bottle that is 10 inches high holds 34 ounces of milk. The sandwich shop is shaped like a milk bottle. To the nearest 1,000 ounces, how much milk could the building hold? So if we fill this up with milk, how much would it hold if a 10-ounce bottle only holds 34 ounces? So we first got to find our scale factor. So that's going to be our A over B. So this means we're going to take since I only give me 34 ounces, we're going to take our corresponding parts, which is the height of our bottle and the height of this bottle. That's going to be 10 over this bottle, which is 480 inches. So this is in inches, this is in inches. If they were not in the same units, we'd have to convert to make sure they're in the same unit. So now we can reduce this fraction by getting rid of the zeros, which means it's going to be 1 over 48. So this is the ratio, this is our scale factor. So now let's take this scale factor, 1 over 48, and let's find our ratio of our volume, which means I'm going to cube both sides. That's 1 cubed is 1. Now 48 cubed is going to be 110,592. So this is the ratio of our, which is our, I'll put it over here, this is our A cubed over B cubed. Ratio of our volumes. So now let's use our ratio of our volumes to help find a missing volume. So the missing volume is going to be, we've got 34 ounces that goes with the small one, 34 ounces for the small figure, and we're looking for X number of ounces for our larger figure. So cross multiply, 1 times X is X. And now we're going to multiply 34 times 110,592. Now this number will come out to be approximately 3,760,128. So this says round to the nearest thousands. Well, the thousands place is going to be the 0 here. This number is not going to round it up, so our answer is going to be approximately 3,760,000 ounces of milk. All right, so let you guys try this one. Pause the video, work it out, and come back to check your answer. All right, so the marble paperweight is shaped like a pyramid and weighs 0.15 pounds. How much does a similarity pyramid paperweight weigh if it is, each dimension is 3 times as large? So if the paperweight is a pyramid and each dimension is 3 times as large, that means we're going to have a 1 over 3 scale factor. That is our A over B. Because remember, if we take one side, we call one side X, and the other side would be 3 times as large, that'd be 3x. Well, the x's cancel, leaving us with 1 over 3. So A over B is 1 over 3. So how much does the similarity pyramid paperweight weigh? So let's take a look here. It says that the first one, the smaller one's going to be 0.15. Let's see how much the larger one is. So we're going to use our ratio of our volume, which means we need to find A cubed over B cubed. So we take 1 cubed over 3 cubed, and that's going to be 1 over 27. So that's our scale factor. And this is our scale factor. This is our ratio of our volume. So we're going to use the 1 over 27 to help find our missing weight. So the small one weighs 0.15. We're looking for the value of the larger one, so we're going to cross multiply 1 times x is x. And 27 times 0.15 is approximately 4.05. This would be in pounds, lbs. So 4.05 pounds. All right, so this concludes our lesson on 11.7. Make sure you look over any of the missing notes you have and fill in any blanks that you need to as well.